All right, guys. He has a name. We are calling him Francis. Hello, Francis. All right, let's go ahead and get started with 8.3, ratios and triangles. This is where things get a little bit trickier in this chapter, and I'm saying that after special right triangles, which I'm sure you thought were super tricky. So let's go ahead and look at everything I've written down here. All right, first of all, I drew this triangle, and what we want to do is we want to describe these sides in relation to this angle B. Okay, so you'll notice this is a right triangle. Okay, across from the right angle is the hypotenuse. So in relation to B, this angle, this will always be the hypotenuse. The hypotenuse is consistent. The side always opposite the right angle. And we're going to say that's side C. Okay, and then we're going to look from angle B, and this is opposite over here, opposite of angle B. All right, so here I've written opposite. Opposite, the side directly across from the given angle. So the given angle here is B. All right, and then here, if you look right from angle B, the side touching it is the adjacent side. We can't use the hypotenuse as the adjacent side because the hypotenuse is just the hypotenuse. So we look at angle B, and then right next to it is the adjacent angle. So the adjacent angle, the side next to the given angle, not the hypotenuse. Okay, this side will not change according to the given angle. That's important to know about these. But the adjacent angle will change according to the given angle. All right, so let's look at some of these examples then, based off of all of this. Okay, so if I'm looking at my first triangle here, I'm using A for adjacent, H for hypotenuse, and O for opposite. So here's angle R, and opposite would be this side TS. Adjacent to it, I will go ahead and put an A for adjacent right next to it, and then the hypotenuse because it's across from the right angle. So we need to get good at labeling these sides, recognizing where our opposite is, where our adjacent is, and where our hypotenuse is. So then we move over to 2, and C is my given angle this time. So I go ahead and I look right next to it. The leg right next to it is A, all right, for my adjacent angle. Opposite, the leg directly opposite of it, is right here, and I'm going to call it O for opposite. And then, of course, the hypotenuse, again, is always directly across from the right angle. So let's look at this triangle, WXY. Our given angle this time is W. I went ahead and highlighted them all in green. The green angles are the given angles, so you would know. All right, well, the hypotenuse again, H, is always directly across from the right angle. That's a given. All right, we moved things around, and so A is our adjacent angle because it's right next door to that angle, the given angle. And then directly opposite that given angle, the opposite is O, this side right here, XY. So now that we can identify the sides, we need to talk about the trig ratios. Okay, so we use the trig ratios, sine, cosine, and tangent to find the lengths of missing sides or missing angle measures. Right? That's why we use trig ratios. So when we say sine of x, right here, or cosine of x, or tangent of x, those represent the given angle. Okay, so whatever the given angle might be. Up here it might be r. All right. And then for sine, we look for the opposite side of whatever that given angle is, and we write it as a proportion. We put it over the hypotenuse. So opposite over hypotenuse. And we think of that as so. All right, sine over hypotenuse. Cosine we think of as adjacent over hypotenuse. So you identify your adjacent side and you put it over the hypotenuse. And we think of that as ca. And then tangent, we identify our opposite side and we put it over our adjacent side. And we think of that as toa. So that will help you remember. So, sine, opposite over hypotenuse. ca, cosine, adjacent over hypotenuse. Toa, tangent, opposite over adjacent. Okay, so let's look at these, at some further examples. All right, I'm going to move this up a little bit, and we're going to practice. So my given angle here for this one is A. So I want to go ahead and I want to find my opposite. All right, well over here is going to be, I'm going to label this orange opposite. All right, well my adjacent to A is going to be this side right here, A. My hypotenuse, per usual, is always across from my 90-degree angle, so H. So sine, remember, is so. So I'm going to look for my opposite, which is A, and that's going to go over my hypotenuse, which, I just got my pens all jumbled, is C. So you would simply perform that ratio. All right, cosine is a little bit different. All right, it's ca. So now I'm going to look for my adjacent, which is B. I'm going to put it on top, and then I'm going to look for my hypotenuse, which is C, and that will go on the bottom. Tangent, toa, so I look for my opposite, which is side A, and I put it over my adjacent, my A, which is A, or which is side B. All right, and those are my ratios. Let's go ahead and look at them with some actual numbers now. So we want to find sine of r. Okay, and I have some side measures this time. So I'm going to start based off of r. I'm going to label my adjacent. I'm going to label my hypotenuse. And I'm going to label my opposite. All right, and sine, that's so, right? So that's going to be opposite, which will be 5, over my hypotenuse, which is 8, 13. Sine of r is 15 over 13, and that's how you do it. All right, this time we're going to solve for sine of x. All right, well, we want to solve for x. So what we're going to look at is we're going to again label. This is our angle this time. And the two sides that I know are my opposite and my hypotenuse. So I have an O and an H. If I look up here at SOHCAHLO and TOA, I know that sine is the only one that I can use because an O and an H is all that I have. So what I'm going to write is I'm going to write sine of 36. I have to use so, right? That's all I have. Equals, and it's opposite, 8 over x. Well, now I have to start solving. So I need to multiply by x in order to get rid of it. And what I do to one side, I have to do to the other. So I have to multiply this by x. All right? So then I have x sine 36 equals 8. Well, I need to get x alone because that's what I'm trying to solve for. So I would do divide by sine 36, divide by sine 36, and I would get x equals 8 over sine 36. And in my calculator, I would plug that in if I can get it to turn on. So I would do 8 divided by, and then in parentheses, I would do sine, hit my sine button right there, sine 36, close parentheses, and hit enter. And x would be equal to 13.61. Okie doke. Go ahead and write down number 3. We're going to work on this one together in class. All right, because now we're going to look at inverse functions. So write this one down, and then I want us to look at inverse functions. All right, so inverse functions. That's going to be sine -1, cosine -1, and tangent -1. And I don't know if you can see on my calculator, let me clear this out, above the sine in yellow is a sine -1. You access that by hitting the yellow button and then hitting sine, and that would be inverse sine. All right, and it's the same for cosine and tangent. So the inverse is only used when we are finding a missing angle measure. So if you notice right here, I already went ahead and labeled them. I did opposite, I did adjacent, and I did hypotenuse. All right, well, the two pieces of information that I have are opposite and adjacent. So that would be TOA, right? Opposite and adjacent. So I'm going to do tangent x equals 3.1 opposite over adjacent, 8.9. Okay, so the whole thing where inverse tangent comes in is I can't divide by tangent x. What I have to do is I have to multiply by inverse tangent. So inverse tangent on this side and inverse tangent on that side. What that looks like is x equals tangent -1, or inverse tangent, times 3.1 over 8.9. When you actually do that in your calculator, let's do inverse tangent, and we will do 3.1 divided by 8.9, close parentheses, and we will get 19.2 degrees. So x equals 19.2 degrees. Okay, again, go ahead and copy down number 2, and we'll do that one in class together also. That is it for 8.3 trig ratios. I will do 8.4 in a moment.